Welcome to Day 8. Today we're looking at message queues and asynchronous processing. This is the secret ingredient that turns slow, synchronous systems into highly scalable, decoupled architectures. Let's look at a real-world analogy first. Think about a busy restaurant. When you order food, the waiter doesn't run to the kitchen and cook it himself while you wait. He writes your order on a ticket, puts it on a queue, and immediately goes to serve the next table. The chefs pull tickets from that queue and cook them asynchronously. The waiter and the chef are completely decoupled. That is exactly what a message queue does for your servers. Why do we need them? If Service A calls Service B directly, and Service B is slow, Service A gets blocked. With a queue, Service A just drops a message and moves on immediately. Queues also act as shock absorbers during massive traffic spikes, and they make retries easy if a service crashes. There are two main messaging patterns. The first is point-to-point, or a standard queue. Here, one producer sends a message, and exactly one consumer processes it. If you have 5 worker nodes listening, only one gets the task. It's perfect for things like video processing or sending an email. Here's how a point-to-point queue looks in code. The second pattern is pub/sub, or publish-subscribe. Here, one producer publishes a message to a topic, and multiple consumers all receive a copy of that same message. It's perfect for broadcasting events, like telling the notification service, the analytics service, and the audit service that a new user just signed up. Here's what pub/sub looks like in a diagram. Now let's look at a real Kafka producer and consumer in Java. The order service publishes an order event to Kafka immediately and returns a response to the user. The payment consumer picks up that event asynchronously and charges the user. If payment fails, the message goes to a dead letter queue for manual review. In interviews, you'll usually choose between Kafka, RabbitMq, and SQS. Kafka is a distributed log that handles millions of messages per second with replay capability. RabbitMq is a traditional broker, great for task queues and routing, but messages are deleted after consumption. SQS is fully managed and the simplest option, perfect for serverless architectures. You also need to understand delivery guarantees. At most once means a message may be lost, but never duplicated. It's fast, but unreliable. At least once means the message is never lost, but could be duplicated, so you need idempotent consumers. Exactly once means perfect delivery, but it's the slowest and hardest to implement. Here's an idempotent consumer in Java. Before processing a payment, it checks if the event ID was already processed. If it was, it skips it. This is how you safely handle at least once delivery without double charging customers. Now let's talk about dead letter queues. When a message fails processing repeatedly, you don't want it blocking the queue forever. Instead, after a set number of retries, the failed message gets moved to a dead letter queue. This triggers an alert so your team can investigate manually. This pattern is essential in production systems. Here's what you should say in an interview. Say, I decouple these services using a message queue. When a user places an order, we publish an event to Kafka. The payment service, notification service, and analytics service each consume independently. This shows you understand event-driven architecture. Or say, for delivery guarantees, I'd use at least once delivery with idempotent consumers. It's the best balance of reliability and complexity. This proves you understand the trade-offs. What should you avoid? Don't make all communication synchronous in a distributed system. Don't ignore failure handling. Always mention dead letter queues and retry strategies. And don't choose Kafka for a simple task queue. That's overkill. Use SQS or RabbitMq instead. Let's check the Day 8 checklist. Make sure you know point-to-point versus pub/sub patterns. Understand the trade-offs between Kafka, RabbitMq, and SQS. Be able to explain the 3 delivery guarantees. And always mention dead letter queues for failed message handling. That wraps up Day 8 on message queues. Practice these patterns, and I'll see you tomorrow for Day 9. Don't forget to like and subscribe.